Good morning everyone. I invite you for this video lecture sections. Myself Dr. J. Sundararajan, working assistant professor of chemistry, Department of Freshman Engineering, St. Martin's Engineering College. I am going to discuss with plastics, properties of plastics and the engineering application of properties. Before going to video lecture, we know about polymer related things, basic concept. First one, what do you mean by monomer? Monomer is a smaller molecule in terms of micro molecules. Number of monomers combined to give large molecule. It is called polymer. Polymerization is a process. Number of smaller molecule combined to give large molecule. It is called polymerization process. Classification of polymerization based on four types. Based on origin source, based on molecular forces, based on structure, based on mode of polymerization. We have only discussed about based on molecular forces. Classified four types: fibers, thermoplastic, thermosetics, elastomers. These four plastic variation on different types of force of attraction involved between the molecule. First one, elastomers, rubber like solid materials in presence of van der Waals force within the molecules. Next one, fiber. Fiber in presence of strong molecular forces between the molecules. This material, hard material and more brittleness. Next one, thermosetics polymer. Thermosetics polymer, presence of intermolecular force of attraction or intermediate force of attraction present in the molecules. Next one, thermosetic polymer. It is mechanical forces present in the molecules. It provides chemical and heat resistance. Next one, what do you mean by plastic? Define plastic. Plastic is high molecular weight in organic material. It is used in molding different types or shapes in presence of catalyst. It's like benzene, hydroxide, etc. Plastic are high molecular weight organic material that can be molded in different types using pressure, temperature and the presence of catalyst. Next one, two types of plastic: thermosetics plastic and thermoplastic. Next one, thermosetic resin or thermoplastic. What do you mean by resin? Resin is a binding molecule in presence of plastic. It is undergo polymerization reactions. During molding process. Thermosetics and thermoplastic. First one, thermosetics and thermoplastic. First one we have discussed thermoplastic polymers. For examples, nylon. Nylons is how to synthesis of nylons. Hexamethylene diamine react with adipic acid. It is followed by nylon 6,6. For examples, intermolecular forces are between the elastomers and the already I clearly tell to you. Elastomers is nothing but rubber. It is a solid material in presence of van der Waals forces, whereas fibers is strong material in presence of intermolecular forces within the molecules. Classification of plastic based on two types: thermoplastic and thermosetics. I will show one videos like what are the types of forces acted between the molecule related to the dipole movements. Van der Waals forces. See these videos. Van der Waals forces and dipole interactions, hydrogen bonding interaction. Show these videos. The dipole moment delta plus delta minus, whereas here delta plus delta minus. Both molecules combine to give weak forces is represented as dotted lines. Next one, dipole forces. These permanent forces like for positive and negative. Difference is the electropoles permanently alignment themselves. Polar molecules align themselves. For example, hydrogen H plus Cl minus, similar to water H plus OH minus. Next one, hydrogen bonds. Hydrogen bond intermolecular forces. Hydrogen molecule large electronegativity difference get strong forces. For example, NH, water, OH. They are really strong dipole. Oxygen represent as red mark, hydrogen representing white marks. Intermolecular forces. Next one, come again, slides. Next one, what do you mean by thermoplastic? Thermoplastic is nothing but is followed by addition polymerizations. Thermoplastic followed by addition polymerizations. For examples, nylon 6 adipic acid react with hexamethylene diamine, they give nylon 6. They are linear polymers or branch polymers. Polymers which are softened and heating and hardened cooling. Repeated heating and cooling having chemical changes. These are proper addition or condensation polymerization. These are made by long chain polymerization, sometimes called polymerization. They are soft and weak and respirated. They are reclaimed from wastage. They are soluble in organic substance. For examples, nylon 6. This image shows that number of monomers. Already I told what you mean by monomer is micromolecules. Number of micromolecules combined to give large molecule. It is called macromolecules or polymer molecules. Here monomers. Number of monomers 1, 2, 3. Number of monomers combined to give large molecules. Number of links between the polymer chain helps to movement. Here thermoplastic. Thermoplastic is three-dimensional polymers or cross-linked polymers. This structure is like cross-linked polymer, for example of thermosettings polymer. If this polymer heat, after that weak forces between the polymer chain easily be broken and heating the polymer can be molded in new shape. The basic things for thermoplastic, first one it is followed by addition polymerization. Second one, it is soluble in organic solvent. Third one, it is soft and cool. Third one, this prepared by addition or condensation polymers. Next one, thermosettings polymers. Thermosettings polymers. Whereas thermoplastic polymers synthesized by addition polymerization, here synthesized by thermosettings polymer followed by condensation polymerizations. The polymer which are hardened during the molding. Second point, the ones they are hardened cannot be reclaimed. The softened, hence these are called permanent settings resins. Whereas thermoplastic resins soft and cooling, hard and heating. Here, once we have the heating, the material cannot be remolded. The permanent settings. Third one, these aqueous cross-linked polymers are 3D structure. Whereas thermoplastic polymers linear or branch structures. The bond retain the structure. The prolonged heating causes charring in the polymers. After long time how to heating this material, it comes to jarrings. These are produced by condensation polymers. These are hard, strong, more brittle. Whereas thermoplastic polymer soft and less brittle. Here hard and more brittle. They cannot be reclaimed from waste. But whereas thermoplastic polymer they can be remolded from waste. Last one, they are not soluble in organic. Whereas thermoplastic polymers soluble in organic solvents. That's for examples, cross-linked polymer, thermoset polymer. Intensive cross-link heating the polymer strong covalent bond between the molecules. Presence of strong covalent bond between the polymer chain can be easily broken. Polymer gives shapes on heatings. Here, linked cross-linked polymers. The number of monomers combines to give thermosettings polymers like these structures. Number of monomers combined to give this look like cross-linked polymer. The links between the polymer chain stop movement between them. Next one, what are the difference between thermoplastic and thermosettings? Already I did with first point, thermoplastic. It is followed by addition polymerization. Whereas thermosettings polymers, condensation polymers. Thermoplastic polymers soluble in organic solvent. It is insoluble in organic solvent. Here addition polymerization, here condensation polymerization. It can be resized after cooling and heating. Cannot be possible here. It is soft and less brittle. Here hard and strong brittle. Soluble in organic solvent, insoluble in organic solvent. Next one, how to synthesis of vinyl chloride or polyvinyl chloride. Vinyl chloride is called monomer. Vinyl chloride is called monomer. Polyvinyl chloride it is a polymer product. This example for thermoplastic polymers. First one, monomer. It is called vinyl chloride. How to synthesis vinyl chloride? Acetylene react with hydrochloride. It is formed vinyl chloride. Whereas vinyl chloride react with Already I told plastic is a high molecular weight in presence of organic material by molding process in the present. Actually react with hydrogen chloride. Presence of catalyst, it is converted to acetate or vinyl chlorides. Polyvinyl chloride. How to obtain polyvinyl chloride? Polyvinyl chloride, for example, of thermoplastics. Number of monomers. Vinyl chloride is monomer. This is called monomer. Number of vinyl chloride combined to a large molecule. This is a macromolecule polymerization product. This is called polyvinyl chloride (PVC). What are the properties of polyvinyl chloride? First one already I told, insoluble of organic solvent. Second one, chemically inert. Third one, it is a colorless, odorless, and chemically inert. Fourth one, high softening melting point. They have two kind of PVC, plastics and plasticides. In presence of some external reagents like are to increase the plasticity. Increase the plasticity is produced by mixing plasticizer like dibutyl perchlorate with PVC resin uniformly. What is the use of PVC? First one, it is produced by raincoats, table covers, and pipes and cables, electric insulated materials. Next one, rigid PVC and plasticized material. Without adding plasticized materials like options of dibutyl perchlorate. It has high rigidity, high hardness, high brittleness. Next one, another one example of thermoplastic Teflon, tetrafluorocarbon. It is a monomer. In presence of catalyst hydrogen peroxide, high temperature and high pressure, it is give polytetrafluorides. This is a commercial name of Teflon. What is the engineering application? It is used to make insulation motors. Insulation motors transform the coils and capacitance. Used to cells, lubricant, oil bearings. Whereas the Teflon uses articles like pump valves, pipes, etc. Used to for large chemicals or chemical storage tank. Next one, bakelite. It is an example. It is an example for thermosetting polymers. How to synthesize bakelite? Phenol react with formaldehyde in presence of acetic acid to give methyl phenol. Phenol react with formaldehyde. How to preparation? It is formed by condensation reaction. It is formed by condensation reaction. Whereas thermoplastic polymer followed by addition polymerizations. Condensation reaction, phenol formaldehyde, presence of acid, alkali, catalyst, proper temperature produced by bakelite. It's okay. Next one, methyls. How to methyl substitute 2, 4 substitution of phenols. Already phenol such as C6H5 OH react with formaldehyde in presence of acetic acid is give of 2, 4 position in presence of methyl. Next, later undergoes the condensation reactions, methyl reaction with another phenol molecules in the formation of novel. Bakelite synthesis followed by 3 steps. First step, how to synthesis of methyl. Bakelite synthesis followed by 3 steps. Phenol react with formaldehyde HCHO in presence of acetic acid. Presence of acetic acid, it is give methyl. 2 types of methyl. One, second position of methyl. Next one, fourth position of methyl. First step, phenol react with formaldehyde in presence of acetic acid. 2 types of product. One is second position methyl, another one is fourth position of methyl. Next step, step 2. Methyl again react with condensation reactions, removed of water molecules. Plus methyl phenols. Removing water molecule, it is called condensation reactions. OH, here CH2 OH. Here removal of water molecules followed by CH2O. CH2 OH, removal of water molecule H2O followed by CH2 C6 H5 CH2 OH. The same way against CH2 OH, this one gives ether linkage. Similar structures here CH2 OH OH this removal of water molecules form ether linkage. It is called resolve. OH CH2 OH. The first step, phenol react with formaldehyde in presence of acetic acid. It gives methyl. Phenol, methyl, two types of one second question, another one is fourth question. The step 2, methyl phenols again react with another methyl phenols, is followed by condensation reaction, elimination of water molecule to make us resolve. Here two types of methyls, both side, second position and the fifth position CH2OH and the CH2OH, followed by condensation reaction, elimination of water molecules give ether linkage. Whereas third steps, step 3, C6H5, C6H4, CH2 OH plus CH2 OH. CH2 OH, followed by condensation reaction, elimination of water molecules, it gives formation of cross-linked polymers CH2 backlight the backlight molecular structures, cross-linked polymers. First, second step, third step, methyl phenols react with another methyl phenols followed by condensation reaction, removal of water molecule to form cross-linked polymers, bakelite. in the undergoes of under condensation reaction with another phenol molecule result in the formation of Novolac linear. First one C6H phenol C6H5OH react with formaldehyde methyl, another react with phenol to give methyl. So it is called Novolac. Long chains of phenol, methanol, plastic covalent characters between methanol is Novolac structure. Further heating linear molecules Novolac structure to form cross-linked polymers. It is called bakelite. The structure of bakelites, cross-linked polymers. Properties of bakelites. The physical property. First one, it is hard material, it is a rigid material. Strong brittleness. Second one, it is stick properties. Third one, it is good ion exchange, OH ions. Good corrosion resistance in atmosphere, CO2 and oxygen. It is insoluble in organic solvent and also insoluble in water. Some applications oriented, engineering application oriented, the image shows here. First one, fabrics material, making the fabric material, for example, welding rods. Activeness of grinding welds and bearings, it is used to paper mills, rolling mills, products of paper industries. Second one, engineering applications of backlights. Engineering application of backlights, so many things. I listed some points for making electrical insulators like switch, plugs and switchboards and heating handlings. Second one, for making fabric materials, wood, paper, abrasive, grinding wheels. Third one, for making of electrical insulators, making of bearings in products, shop in paper mill and rolling mill, making of mobile molding articles, water purification methods. Once again, I summary for this section. First one, we know how many types of plastics: thermoplastic and thermostatics. So belongs to the molecular forces. What are the molecular forces operated between two polymers? Thermoplastic and thermostatic. Thermoplastic operate by intermediate force of attractions, whereas thermostatic polymers is mechanical forces. Second one, thermoplastic resin and thermostatic resin. What do you mean by resin? Resin is a binding molecule in presence of plastic is undergo polymerization reaction during the molding process. Next one, how to synthesis of thermostatic polymers and thermoplastic polymer. First one, we have discussed thermoplastic polymers. For example, nylon. How to synthesis of nylon or polyvinyl chloride. I take polyvinyl chloride here. Vinyl chloride is how to synthesis vinyl chloride. Preparation of vinyl chloride. Acetylene react with hydrochloric acid in the presence of catalyst. It gives vinyl chloride. Vinyl chloride react with catalyst in presence of benzyl hydroxide. It gives polyvinyl chloride. Vinyl chloride molecular formula CH2 double bond CHCl in presence of heat and pressure. In presence of catalyst, benzyl peroxide gives polyvinyl chloride. Polyvinyl chloride physical properties. What are the physical properties of polyvinyl chloride? Polyvinyl chloride is about a white color, odorless, into chemical inerts. It is insoluble in water. It is soluble in organic solvent. It is a good electrical insulating properties. Next one, polyvinyl chloride applications. It is production of pipes and cables and table covers, etc. Next one, two types of PVC is there. One is plasticized PVC. Another one is rigid PVC. Plasticized PVC in presence of plasticized, it is increase the softness. Rigid PVC, the hard materials, polyvinyl chlorides. Another one examples, tetrafluorocarbon, CF2 double bond CF2 is a monomer tetrafluorocarbon. It's a presence of catalyst. It gives polytetrafluorides. It is commercial name Teflon. Some engineering application is the next one. Bakelite. Bakelite belongs to thermostatic polymer. How to synthesis bakelite? Bakelite monomer is called phenol. React with formaldehyde in presence of acetic acid. It gives 2, and another one is 4. Two types of methylar. One is second position methylar. Another one is fourth position of methylar. The methylar again combined with followed by condensation reaction. It's elimination of water molecule. This give methylar Next one, two types of methyl is followed by condensation reaction. It gives ether linkage. It is called resorb, and the another one structure novolog. Novolog again react with followed by phenol. It gives backlights, cross-linked polymers. What is the physical properties of backlights? First one, it is hard materials and rigid material, more brittleness. It is insoluble in organic solvent and water resistant and heat resistance. What are the applications of backlight? They cross-link this. This slide shows that cross-link resins backlights. Properties of backlights. Already I told clearly rigid properties and hard materials. Second one, sticky properties. Third one, anion exchange properties. Only exchange of anions. It's a more application for water analysis or water treatment technology by using resins. The exchange of anions. They are excellent electrical insulating material. It's a great application for backlights. Some applications of engineering materials. First one, fabrics materials. Second one, grinding wheels. Third one, propeller soft mills and the bearings. This making of bearings. For making electrical insulator parts of switch blades and heat handlings. Second one, for making fabric materials. Third one, for making bearings. Fourth one, water exchange or water treatment technology, only exchange of anions. It is used by resin, anion resins. Third one, it is corrosion resistance and also enhanced heat and thermal resistance. And water purification method already told is the anion exchangers, making of molding articles. This is only one thing we have to keep in mind. Autosynthesis of backlight. It is formed by condensation reactions of phenol and formaldehyde in presence of acid or alkali catalyst. So one thing is applied fire. Phenol. Its OH group is there. It is react with alkaline. It's react with alkaline. The catalyst at proper temperature produces backlight or phenol formaldehyde resins. Here, C6 rectified OH. It is called phenol formaldehyde. The produce of active ions of catalyst is name of the catalyst acetic acid. It gives phenol methyl. And another terms, fourth position of phenol methyl. If they undergo condensation reaction means elimination of water molecule. The same way, second position methyl react with phenol, elimination of water molecules minus H2. This give novel linear polymerizations, novel structure. Second one, long chain phenol, methanol, plastic covalent cross-linked polymers build up three-dimensional structures. Here, this image shows that three-dimensional structure. It is a backlights. It is represent as polymer molecules. Further, the heating the linear polymer over from cross-linked polymers with chain presence of hexamethyl tetramine resulting in the formation of backlight. This slide shows that clearly explained. Backlight cross-linked polymer are three-dimensional polymers. This expansion of anion exchanger of resins water technology using three types of resin is there: cation exchanger and anion exchanger and mixed bed. This most probably we are using anion exchangers, backlights materials to only exchange of negative charges. Water purification method is main application for water purification method and making of molding articles, making of bearings used in proper shaft paper industry and rolling mills. For making electrical insulators like black switch and heater handles. That's it. Thank you for everyone.